Explain your strategy. Use place value words. Show why it works.
Solving a math problem on paper can sometimes feel like following a strict set of rules. The symbols often look static, as if there is only one way to move from the problem to the answer. Inside the tens and ones burrow, we treat numbers as physical objects resting on a carved mat. Every two-digit number here is a literal pile of heavy tens rods and small ones units. Made of wood and slate, Kit can gently nose them apart. The law is simple. Moving these piles around never creates or destroys a single wooden block. The total stays the same. Because numbers follow the rules of the physical world, we can rearrange them into whatever grouping makes the addition or subtraction easiest for us. Look at 34 plus 52. We can find the total by breaking these piles down into their basic parts. First, Kit splits the 34 pile into 30 and 4. She does the same for the 52 pile, separating it into 50 and 2. Now she groups like with like. She pushes the tens rods together. 30 plus 50 equals 80. Next, she merges the ones units. 4 plus 2 is 6. Finally, she slides 80 and 6 together to get 86. This method of adding tens to tens and ones to ones is organized because the physical blocks show that the total amount remains the same throughout the entire split. Sometimes a problem starts with a small number, like 8 plus 45. Counting up from 8 takes quite a bit of time, but Kit can simply trot to the opposite side of the mat to see the piles from a different angle. By changing her perspective, the equation becomes 45 plus 8. Starting with the larger pile makes reaching the final total of 53 much faster. Swapping the order works because moving physical piles across the mat doesn't change the actual amount of wood in the heap. Subtraction follows this same logic. To take 23 away from 58, Kit removes the pieces in stages. Instead of trying to take 23 blocks at once, she breaks the amount down into 2 tens and 3 ones. She starts by sliding away the heavy tens rods first. Taking 20 away from 58 leaves 38 on the mat. Then she noses 3 small ones units away from that 38, leaving a final total of 35. The blocks remaining on the mat match the result of our two-step subtraction. Taking the pieces away in sequential phases removes the same amount of material as subtracting them all at once, just with fewer parts to track at one time. Our results, 86, 53, and 35, are the result of the same physical logic. Understanding how these blocks move makes it easier to see why the math steps we use on paper actually work. We can split the piles, swap them, or take them away in pieces, because moving the blocks never changes the amount originally there. So, to add 7 plus 62, would you keep the order or swap the piles first? You can now use the logic of the piles to choose whichever path is easiest.
Tens plus tens. Ones plus ones. Reasoning proves the sum.